All right, so using substitution, if you had to pick which one you want to rearrange, I would choose this one, the bottom one, because the y doesn't have any coefficients besides 1, so that would be the easiest one. So I'm going to call this equation 1, equation 2. So I'm going to leave the first one alone. And the second one, I'm going to rewrite it. So if I do plus 8x and plus 8x on both sides, that goes away, and I'm left with y equals 8x minus 12. And that's going to be the version that I'm going to use. So equation 2 has two versions, the original one and this one. They're both the same. Now that I know what y is, I can go back to equation 1. So here's my substitution. Right, so in equation 1, right, I'm going to go 4x plus 3 times y, and I know what y is. It's 8x minus 12 equals negative 8. So now it's just solving. 4x plus 24x minus 36 equals negative 8. That's 28x combined like term minus 36 is negative 8. Plus 36 plus 36. That goes away. We get 28x equals 28. Divide both sides by 28. And I have my coordinate x equals, so let me write that, x equals 1. So my point intersection, I have one coordinate. I need a y coordinate. So I know what x is. Pick either the original equation, pick either the original equation or one of the versions of equation 2 to find what y is. So I'm going to change colors. To find what y is, to find y, to find y, I'm going to use this one. Y equals 8x minus 12, right? I'm going to replace the x as 1, and I get y equals 8 times 1 minus 12. Y equals 8 minus 12, and y equals negative 4. So there's my point of intersection. So those two lines intersect here. To do a check, I'm going to take this point, so I'm going to go check. Replace 1 and negative 4 on both equations. Equation number 1, if I substitute already, I get 4 times 1 plus 3 times negative 4, and that equals negative 8. 4 times 1 is 4. 3 times negative 4 is negative 12 equals negative 8, and it's checked. So with equation 1, it's good. Equation 2, I'll choose this version here. Y equals 8x minus 12, so I get negative 4 equals 8 times 1 minus 12. Negative 4 equals 8 minus 12, and as you can tell, that point satisfies equation 1 and equation 2. Okay? I'm going to go 1 and 1, one from the left, one to the right. Okay, so now different methods, elimination. So pick, doesn't matter who you want to pick. If you want to pick the y, to eliminate the y's, you're going to have to multiply the top by 3 and the bottom by 8 to get 24, right? On both, for both coefficients of y. Or you can just multiply, put a little thing, multiply this one. Right, so let me write it like that. Multiply this line by 2. If I multiply that line by 2, I get negative 10x plus 6y, and then 2 times negative 9 is negative 18. And I'm going to copy the line on top, so I get 10x minus 8y equals 4. Now I can do elimination, so I'm going to add, if you look at the coefficients, one is positive 10 and negative 10. You don't want to subtract these, you want to add. 10 plus negative 10 is 0x, so that goes away. Negative 8y plus 6y is negative 2y. 4 plus negative 18 is negative 14. Divide both sides by negative 2. And y equals 7. So now I get to pick one of the equations to find x. So let's just, I'll pick this one, the first one right here. So 10x minus 8y equals 4, and then I'll replace the y with 7, so I get 10x minus 8 times 7 equals 4. 10x minus 56 equals 4. Under the plus 56 on both sides, I get 10x equals 60. Divide both sides by 10, and x equals 6. So our point intersection is 6 and 7. Now, let's do a check. So again, check, I'm going to pick the equation 1 and equation 2. All right, and you're going to replace x and y with 6 and 7 and see if it works. So in equation 1, which is right here, let me write 1. It's 10 times 6 minus 8 times 7 equals 4. That's 60, that's 56, and you can tell right away that that works. In equation 2, it's negative 5 times 6 plus 3 times 7 equals negative 9, right? Replacing this x with 6 and this y with 7. Negative 30 plus 21 equals negative 9, and negative 9 equals negative 9. So you work for both. It's that simple. Right, so let's go to this one. Y, it's already, this one is even easier. We already know what y is. Y equals negative 2. So we're going to go back. So let's do a substitution. Right, so this is equation 1. This is equation 2. So we know that y is negative 2. So let's take that and replace this y as negative 2. So we get 4x minus 2 times negative 2 equals 8. 4x and negative 2 times negative 2 is positive 4, which equals 8. Subtract 4 from both sides. We get 4x equals 4, divide both sides by 4, and x equals 1. So our point of intersection is 1, 2. Right, x and y. Let's do our check. So to do our check, we're going to use both equations, 1 and 2, and see if it works. So in place of x and y, you replace it with 1 and 2. So in equation 1, we get 4 times 1 minus 2 times 2 equals 8. Sorry, it's negative 2. And 4 times 1 is 4. This is negative 2, and that's also positive 4. And we get that a equals 8 for equation 1. In equation 2, y equals negative 2. Let's replace the y with negative 2. And as you can tell, that also works. So equation 1 and equation 2 both are satisfied with a point of intersection 1, negative 2. Now on the right side, we do elimination. So again, pick who you want to get rid of. This one doesn't matter. So either you multiply the bottom by 3 to make that 5 or 15, or the bottom by 9 to make the coefficient of y a 9. Or you can multiply by positive 3 or negative 9. It's really up to you what you want to multiply with. So as long as you multiply everything, right, by that factor. So I'm going to take and multiply the bottom line by 3. You know what? And I'm going to make it a negative 3, just to make it a little different. So top line doesn't change, so it's negative 15x plus 9y equals 27. The bottom line, I'm multiplying everybody by negative 3. If I do that, I get positive 15x. So negative and negative positive. Negative 3 and negative y is positive 3y. And then negative 3 times 17 is negative 51. I can now add. I think adding is easy than subtracting. So if I add, let me change colors, put a plus sign here. If I add the first equation with the second one, the negative 15 plus 15 is 0x. 9y plus 3y is 12y. And this is negative 24. Divide both sides by 12. And y equals negative 2. Good. Now pick any equation to find the value of x. I'm just going to pick this one because this has a smaller coefficient. So I'm going to substitute in equation 2 over here, the original equation 2, this guy right here. So it's negative 5x minus negative 2. I replace the y with negative 2 equals 17. Negative 5x, this becomes plus 2 equals 17. We're going to do minus 2 on both sides. And negative 5x equals negative 15. Sorry, positive 15 divided by negative 5 divided by negative 5, and x equals negative 3. So our point of intersection is 3, negative 3. Let me write that a little better. Negative 3, comma, negative 2. So that's our point of intersection, right? Our solution. So let's see if this point satisfies both equations. So let's do our check. So check in equation 1, which is this one, negative 15x plus 9y plus 27 is negative 15 times negative 3 plus 9 times negative 2 equals 27. Let's see if that's true. Negative 15 and negative 3 is 45, positive. 9 times negative 2 is negative 18, equals 27, and 45 minus 18 is 27. So with equation 1, we're good. In equation 2, the negative 5x minus y equals 17, so it's negative 5 times negative 3 minus, careful here, negative 2 equals 17. Let's see if that's true. Negative and negatives are positive, so I get 15, and I get negative, negatives are positive, and I get 2. And equation 2, both sides, both expressions equal each other. Okay. Scroll down. All right, so far, so good. So the left side we're doing substitution, the right side we're doing elimination. So on the left side here, again, let me write 1 and 2. I would pick equation 2 to change because the coefficient is 1. So I'm going to take the line. So this one, in equation 2, I'm going to do plus 7x plus 7x. This goes away. I'm left with y equals 7x minus 23. So done. Let me write this next. So that equation changes to y equals 7x minus 23. Okay. Now I'm going to replace this over here in equation 1. So here's my substitution. I get 14x minus 2 times 7x minus 23 equals 46. Now it's just a matter of doing all that procedure. 14x minus 14x minus 23 equals 46. This goes away, and we get negative, oops, sorry, I made a mistake here. So that's 14x minus 14x plus 46 equals 46. So in this case, 46 equals 46, right? And hang on 1 second, I just want to make sure. First quit. And what is that? 14x minus 2y equals 46. And for this one, we write that there's an infinite number of solutions, which I think is what I wrote on the class. Infinite number of solutions. Okay, because if you think about it, let me change equation 1. You get 14x minus 2y equals 46, and I'll show you in a second what I'm talking about. Minus 14x minus 14x. These two go away. We get negative 2y equals negative 14x plus 46. We're going to divide everything by negative 2. And y equals positive 7x minus 23. So notice that equation 1 and equation 2 are exactly identical. So both lines are on top of each other, right? With both lines. So you have 3 conditions here. We have one where we have a line like this and another one here. So that would be a point of intersection and where the solution is a single point. We have something like this where you can have parallel lines and there's no solution because those 2 lines don't intersect. So there's not a single point or points in this case that satisfy both equations. But then we have a situation like this. We have one line, then let me change colors, and the other line is right on top of it. So, right, they're all right on top of each other. So we have every single point on this line satisfies both lines. And how many points are there? Infinite number of points. Okay. Following one. Pick one again. Like I said, pick either the x or the y's. I go for the easy ones. I want to get rid of the y because if I do that, the only thing I have to do is multiply the bottom one by 2, which gives me 8y, and then that's it. So if I want to change the or eliminate the x, I would have to multiply the top by 4 or the bottom by 7 so that they have a common coefficient. I don't want to do that. So let's multiply the bottom one by 2. Multiply the bottom one by 2, I get 8x. plus 8y and equals 24, right? Multiply everything by 2. The top line stays the same. Now I just got to add or subtract. In this case, because we have negative 8y and positive 8y and they're different, so we add. Negative 7x plus 8x is just x. The y's goes away. Negative 23 plus 24 is just 1. Look how easy that was. X equals 1. Let's pick one of the equations to find y. So is there an easier one? No. So let me pick this one right here, this equation. So negative 7x, or I'm going to replace the x with 1, minus 8y equals negative 23. Negative 7 times 1 is negative 7, minus 8y equals negative 23. You're going to do plus 7, plus 7. You get negative 8y equals negative 16. Divide both sides by negative 8. And y equals positive 2. So our point of intersection is 1, 2. Check. Again, we're going to have to substitute this point in for x and y in equation 1 and equation 2 and see if it does work. So equation 1, so here's a check. 7 times 1 minus 8 times 2 equals negative 23. Let's see if that's true. That's negative 7. This is negative 16. And that is true. For equation 2, we got 4x plus 4y equals 12. So 4 times 1 plus 4 times 2 equals 12. And that definitely equals 12, right? So these two, this point exists in this line and in this line, right? It's that intersection right there. Okay. All right, so not too difficult. This one, I want to change the top one. I'm going to change this. So let me bring that over here. 5x plus y equals 8. And again, because 8 has a coefficient of 1, it makes my life easier. Minus 5x, that goes away. Y equals negative 5x plus 8. So I'm going to rewrite this equation as y equals negative 5x plus 8. Okay. So now I'm going to substitute. I know what y is, right? So I'm going to take that and replace it right here instead of this y in equation 2. So I get negative 3x plus 2 times, instead of the y, I'm going to write negative 5x plus 8 equals negative 10. Negative 3x, negative 10x plus 16 equals negative 10. Combine like terms, right? I get negative 13x plus 16 equals negative 10. Minus 16 on both sides, and we're going to get negative 13x equals negative 26. Divide both sides by negative 13. X equals positive 2. So now I'm going to take this, right? I found x, I need to find y, so let's put it over here. So we get y equals negative 5 times 2 plus 8. Y equals negative 10 plus 8. And obviously y equals negative 2. So there's my point of intersection, 2, negative 2. All right, so those two lines intersect there. We do a check, plug this value and this value, the x and the y, in equation 1 or 2. So you can use, so for equation 1, you can use either version, the 5x plus y equals 8 or y equals negative 5x plus 8. They're the same thing, just written in a different manner, right? So in equation 1, I'll pick this one, the second version. So we get y, which is negative 2, equals negative 5 times 2 plus 8. Negative 2 equals negative 10 plus 8. And negative 2 equals negative 2. Check. Equation 2, which is this one right here, it's negative 3 times 2 plus 2 times negative 2 equals negative 10. Negative 3 and 2 is negative 6. 4 times negative 2 is negative 4. And if you combine those two, you get that. So that is truly correct. This one, on the right side, we do elimination. Who do we want to get rid of? Pick the x or the y. I'm going to pick x. I'm going to pick get rid of the x's. So I'm going to multiply the bottom line by 3. Let me rewrite the top line. Nothing happens to the top. the bottom line, if I multiply everything by 3, I get 3x. 3 times negative 5 is negative 15y. And 3 times 18 equals 54. I'm going to add, change colors here. Negative 3 plus 3x, negative 3x plus 3x is 0, so that those two go away. Negative 10y plus negative 15y is negative 25y. Negative 4 plus 54 is 50. Divide both sides by negative 25, and y equals negative 2. I know I have y, I have to find x, so to find x, let's go find x. Pick an equation. Let's replace that negative 2. So I'm going to let's take this one right here. Right, let's take that one. So x minus 5 times negative 2 equals 18. X plus 10 equals 18, minus 10 on both sides, and x equals 8. So the point of intersection is 8, negative 2. Now we gotta go and do our check. We're gonna replace x and y in equation 1 and equation 2, see if it works. So negative 3 times 8 minus 10 times 2 equals negative 4. See if that's true. It's negative 2 here. So that negative 10 and negative 2 is plus 20 equals negative 4. And then with equation 1, we're good. Equation 2, x minus 5y equals 18. So we get 8 minus 5 times negative 2 equals 18. 8, negative 5, negative 2 is positive 10. And 18 equals 18. So we're good there as well. That's it for that side. Turn the page over. Uh-oh, I need the equations. Oh, I do have it. So the first one here, bring it up like, make this bigger. Can I? No, it's smaller. There we go. So the first one here, the equation, right over here, y equals 5 over 7, x plus 4, y equals negative 1 over 7, x minus 2. So let's graph the first one. So y-intercept is 4, 1, 2, 3, 4. 1, 2, 3, 4. It's a positive slope, so it's changing y is 5, changing x is 7. So it's, let me count, 1, 2, 3, 4, 5 up and 7 across. So because it's going to be positive, I'm going right. 1, 2, 3, 4, 5, 6, 7. Can I make one more point? Well, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. There's my other point. So I can't fit any more points. I'll use those 3. Okay, and we're doing, let me just make that a little better. Just a tiny better. Bring that down a little bit. Okay, so let me make the points just a little bigger. Now I'm going to, so what is this? Give it a name. Y equals 5 plus 4. And the other one is a negative slope. I'm going to do it in blue. This negative 2 is my y-intercept, so right here. And it's changing y is 1, changing x is 7. So 1 down. And this time, if I go down, I'm going to have to go right because it's negative slope. So 1, 2, 3, 4, 5, 6, 7. So another point. Let me see if I can find another point. If I go up, I have to go left. 1, 2, 3, 4, 5, and I'm going to circle that because that's our point of intersection. That's where those two lines meet. All right, so there we go. Give this line a name. And our point of intersection is right here, and the solution is 1, 2, 3, 4, 5, 6, 7. Negative 7 to the left, and 1 down. There's my solution. So those 2 points, those 2 lines, sorry, intersect at that point. Let me check. So go to equation 1, substitute. So let's do the first one. Y, which is negative 1, 5 over 7 times x is negative 7 plus 4. negative 1, that crosses away. I have negative 1 left over. That becomes negative 5 plus 4, and negative 1 equals negative 1. So it worked for the first equation. The second equation, y, again, is negative 1, equals negative 1 over 7 times x, which is negative 7, minus 2. Negative 1, that simplifies to 1. Negative times a negative is a positive, so I get 1 minus 2, and then negative 1 equals negative 1. So that point of intersection, as again, it is on both lines, and that's just your check to make sure. Okay. On the right side, our equation. Simpler. X equals 7. And the second one is y equals negative x plus 9. Seriously? All right. Let's do x equals 7. 1, 2, 3, 4, 5, 6, 7. Here it's just x equals 7. It's undefined, so our slope is going to be vertical. My slope here. Stretch that, all that. I have it right. Just move the line just a little bit. There we go. That's a line x equals 7, right? Move that a little bit. Right, x equals 7. Our second line, the y-intercept is positive 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Our slope is negative. Let me put a 1 there, right? 1 over 1. So 1 down, 1 to the right, or 1 down, 1 to the left, depending on which way you're doing it. So it's a negative, so our line has to look like this. So if I go 1 down, I have to go to the right, right? When I connect those 2 points, we're going to have a negative slope. And for this one, it's nice because there's so many points that we can actually, and we can see right here, it's our point of intersection. I'll make that circle a little bit bigger. Right, so that one's a simple one. Now, let's put the line correctly in this place. There we go. And you can tell where those 2 lines meet. Those 2 lines meet at, okay, so it's not perfect. Right there. Those 2 lines meet at 7. That point right here is 7, comma 2. Let's replace this in equation 1 and 2. So equation 1 is x equals 7. So replace the x value with this one. Remember, that's x and y. So we get 7 equals 7. So that's good. In equation 2, we have y equals negative x plus 9. So y is 2 equals negative x, which is 7 plus 9. And 2 equals negative 7 plus 9. It's 2. And it worked for both equations. So that point exists on top of both lines. All right, so nothing to it. Question over here. Y greater than, pick a different color. Y greater than 4x minus 3. I'm going to do a dashed line here, just to remind me that when I do my line, I use dashed line. And the other one is going to be y greater than or equal to negative 2x plus 3. And this one, I'm going to use a solid line. Okay, I saw someone doing that in class. I'm copying you. So let's do the first one. It's minus 3 is my y-intercept. 1, 2, 3. It's a positive slope, meaning my line has to go like that, correct? So it's 4 over 1, right? So 4 up and down and 1 left and right. Changing x, y is 4, changing x is 1. So let's go up. 1, 2, 3, 4, and 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. That should be enough points. We're using a dashed line. Use a ruler, please. Let me just move this. Okay, right there. Let me get the points a little bit bigger. Okay, 1, 2, 3, 4. There's a point there. 1, 2, 3, 4. There's a point here. 1, 2, 3, 4. There's a point there. Okay, so we have to do a little test. Let me give this line a name. Y is greater than 4x minus 3. Pick a point. 0, 0 is always nice if you can. and replace the y and x. So if you place y and x with 0, you get 0 greater than -3. And that's true. So where 0, 0 is on this side, on top of the line, right? On the left side of the line. So we're going to, that means that every point on this side also makes that inequality true. All right, and if you have time, you can pick other points and verify that as well. But I'm just going to pick one. The second line, let me change colors, green. Y is greater or equal to -2x plus 3. The y-intercept is 3, so 1, 2, 3, right here, y-intercept. And it's a negative slope, so the line is coming down like that. So it's -2 over 1. 2 up and down, 1 left and right. Changing y is 2, changing x is 1. So if I go down, 1, 2, I go 1 to the right, 2, 1 to the right, 2, 1 to the right, and I have enough points to have my line. You have to use a solid line for this one. Okay, so all right. So let me just move this. Okay, let me make the green points just a little visible. And again, we do a check. Let me give this line a name. Y is greater or equal to -2x plus 3. Let's substitute with 0, 0. See what happens. Times 0 plus 3, and I get 0 is greater than 3. That's or equal to 3. And that's definitely not true. So we don't want, right, on the solid line, we don't want this area here. We want the area above the line. All right, so let me just write that a little bit lower here. We want this line. So 0, 0 didn't work, and 0, 0 is right here. So we don't want this area. We want this area. So there's going to be a part, an area there where the blue and the green will meet. And that is your solution area. I'll put a big S here. Okay, so any point in that area satisfied both inequalities. Any point only in the blue area satisfied the first inequality, and any part only in the green area satisfied the second inequality. So let's pick a point that's only, is in our solution area. So let me pick 0 and 1, 2, 3, 4, 5, 6. Let me pick 0 and 6, which is right here. And that should work for both inequalities. So let's try the first one. We get 6 greater than 4 times, 6 greater than 4 times 0 minus 3. 6 is greater than -3. That's true. Let's take the second equality. 6 is greater or equal to -2 times 0 plus 3. 6 is greater than or equal to 3, and that's also true. Okay, so, and if you wanted to, pick more points in that solution area and play with it. Last question, I think. Okay, so the last problem is 4x minus 3y less than 9, and the other one is x plus 3y greater than 6. So we have to make some changes. So let's do minus 4x here, minus 4x. This goes away. -39 less than -4x plus 9. Divide everything by -3. You get y, switch signs, 4 over 3x minus 3. So that's the equation we're going to be working with. And this one, let's do minus x on both sides. We get 3y greater than minus x plus 6. Divide everything by 3. We get y greater than negative 1/3 x, right? There's a 1 there, plus 2. So those are the two equations we're going to graph. We're going to use dashed lines for both. This is going to be a negative slope, and this is going to be a positive slope, just so that we know. Y-intercept is -3. We're going to go 4 up, 1, 2, 3, 4, and 3 to the right. 1, 2, 3. 1, 2, 3, 4, 3 to the right. All right, and we're going to use dash lines. All right. Okay. Let's label this. we're going to pick 0, 0, see if it works. So if I put 0, 0, I get 0 greater than -3, because 0 times 4/3 is 0. And that's not true. So we want, so that is true, sorry. So we're going to shade this side. Right, 0, 0, 0 is greater than -3. So we're going to shade that side. Oops. Try to make it pretty. All right, let me erase that. The other line, is orange, is y is greater than -1/3 x plus 2. The y-intercept is here. So changing y is 1, changing x is 3. So if you go, so it's going to be a negative slope. So if I go down, I have to go 3 to the right. Down, 3 to the right. Down, 3 to the right. If I go up, I got to go left. We have enough points for, again, dash line. And let's give this a name. What is this? Y greater than -1/3 x plus 2. Let's pick the point 0, 0 and see if it works. So 0 greater than 2, right? Because -1/3 times 0 is 0 plus 2. So 0 greater than 2? No, it's not true. So if it's not true, we don't want the side where 0, 0 is, but we want the side the other opposite side. So right away, you see the two areas that intersect. Right, so orange, only orange satisfies the second inequality, only blue satisfies the first inequality. Orange and blue area satisfies both inequalities. So we'll put a big S here. That's big. Pick a point in here. Let's pick a point with 0. So I'm going to pick 0 and 1 just to be safe. 0 and about 7. That's going to be my checkpoint. So let me place that in both inequalities. Let me erase that because we don't need it. First inequality, y greater than 4/3 x minus 3. So I place 0. 4/3 times 0, times 7. I should have picked another number. You know what? Instead of 0, 7, because I don't want to deal with this mix up, I'm going to pick 0, 9. Okay, so my y value. No, that doesn't make any sense. Hang on a second, guys. No, it's actually 0, 9. 0, 7 was just fine. So, y equals 7, greater than 4/3 times 0 minus 3. 7 is greater than -3. That's true. So equation 1, equation 1, that works. Equation 2, we get y inequality. 1 it worked. Inequality 2, y greater than -1/3 x plus 2. So let's replace 0 and 7. So we get 7 greater than 1/3 times 0 plus 2. 7 is greater than 2. That also worked for the second inequality. Okay? And that's pretty much it.